During the times kings ruled the world, they used to fight each other with many kinds of weapons during war. One of the weapons that was commonly used was a cannonball. They will have something called table of randoms, which tells them how much gunpowder should be used and the angle at which the ball has to be fired such that it creates a certain amount of damage. They will estimate the distance at which the enemy is and then aim the ball. But once the research of the scientist Galileo came into light, one thing everyone understood is that when there is no air resistance, then the object that is fired will follow a quadratic curve. Since then, people started working on the field of quadratics. Just like how we can find the target point by solving the quadratic equation, by solving quadratic inequality, we will be able to find the range of damage caused by the cannonball. So you might now have understood how important it is for army people to know how to solve a quadratic equation. So let us now jump into the topic and learn what is a quadratic inequality and how to solve them. Before we start, as usual, let us recall few terms in linear inequality. When the highest power of the variable of an equation is 1, we call it a linear equation. By solving this equation, we can find the value of the unknown variable. In a linear inequality, instead of an equal to symbol, we will have less than, greater than, less than or equal to, or greater than or equal to. When we solve this inequality, we will not get just one solution for the unknown variable. We will get solution as intervals, that is, we will get a range of solutions. Just like how we find solution of a linear equation by adding, subtracting, multiplying and dividing on both sides of the equation, the same technique is used to solve an inequality and find the range of its solution. One thing to note is that when we multiply or divide by a negative number in an inequality on both sides, the operator on the inequality will change to its opposite operator. For instance, let us consider this inequality minus x less than 4. To solve this inequality, we can multiply by minus 1 on both sides. Then the operator less than will become greater than. That is, minus x less than 4 is same as x greater than 4. Or if we have the inequality x divided by minus 2 is greater than or equal to 3, then by multiplying by minus 2 on both sides, we will get x is less than or equal to minus 6. You might wonder what is the need to multiply on both sides by a negative integer. Let me tell you why. A variable means that its value will change all the time. Suppose you have 2 less than 4. The operator of this inequality will not change when you add, subtract, multiply or divide by a positive integer on both sides. In the same way, when it is added or subtracted by a negative integer, the inequality still holds true. But when you multiply or divide by a negative integer, then the inequality will not hold true, but the inequality will change to the opposite operator. Just like linear inequality, quadratic inequality will also have its solution as a range of values. Now let us consider a quadratic inequality and its graph and see how the range of values of x will be like. We know that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0 and its graph will be a U-shaped parabola. Depending on the value of a, whether it is positive or negative, the parabola of the equation will be concave up or concave down respectively. To learn about these concepts in detail, check out the link given in the description box. To understand it even more easily, let us consider the inequality x squared minus 4x plus 3 is strictly greater than 0 and its corresponding graph. Let us denote this quadratic by y. Now where will the solution of this inequality be? Where will the values of the curve x squared minus 4x plus 3 be greater than 0? You can see that the curve is positive to the right of 1 and to the left of 3. Just like how we get values of x when we solve a quadratic equation, the solution of these inequality will also be the values of x. The places where the curve is greater than 0, value of x in those places will be the solutions. And so, we get the solution of this inequality to be a set of all x such that x belongs to the open interval minus infinity, 1 and x belongs to open interval 3, infinity. You may notice that 1 and 3 are not solutions to this inequality. That is because the inequality x squared minus 4x plus 3 is strictly greater than 0. But if the inequality had been greater than or equal to 0, then the values of 1 and 3 of the quadratic will also be the solutions of this inequality. Now, if the inequality had been x squared minus 4x plus 3 is less than or equal to 0, we will see how the solution changes. The range where value of the curve is either 0 or negative will be the solution. And so we get the solution to be the set of all x such that x belongs to the closed interval 1, 3. We know that a quadratic curve will meet the x-axis in either two places or one places or no place at all. In such a case, what will the solution of this inequality be? Suppose that the curve doesn't meet the x-axis but stays above the x-axis. As the curve is above x-axis, value of the curve will be greater than 0. And so, the solution to that curve will be all the values, that is, set of all x such that x belongs to R. You will also see that the equation ax squared plus bx plus c less than or equal to 0 will have no solution at all because the curve y neither touches 0 nor takes the negative value. As a curve can also face downwards, how will the solution of this type of curve be? Suppose that the curve meets the x-axis as two places, then for the range of values of x that is between the solutions, y will be greater than 0. And for the values of x to the left and right of the curve, y will be less than 0. So we saw how the solutions can be represented graphically. We shall now see how to solve these inequalities. Now, there are two methods to solve a quadratic inequality. Number one, algebraic method, and the other is graphical method. In both the methods, we will assume the quadratic inequality to be a quadratic equation and then we will solve it. As we know, there are three methods to solve a quadratic equation. Number one is factorization method, and this method can be used to solve only certain quadratic equations. This method cannot be used to solve equations which does not have a rational number as its solution. Number two is quadratic formula method. In this method, we use the formula x is equal to minus b plus or minus square root of b squared minus 4ac by 2a to find the solution of the quadratic equation. Number 3 is completing the square method. In this method, we will rewrite the equation as an equation of complete squares and then find the solution. The second and the third method, which I have mentioned above, can be used to find solutions of any quadratic equation. Okay then, let us now see how algebraic method can be used to solve a quadratic inequality. First, let us write the equation in factor form. Then, let us find the product of the constant 8 and the coefficient of x square, which is 1. And the product will be equal to 8. Now let us find the factor pairs of 8. We get those factor pairs to be 1 and 8, minus 1 and minus 8, 2 and 4, minus 2 and minus 4. The above pairs, when you multiply each pair, we get 8 only. So now, can you guess which of these pairs, when added together, will give us the coefficient of x, that is minus 6? Yes, when we add minus 2 and minus 4 together, we will get coefficient of x, that is minus 6. Now let us replace these two values in the place of minus 6 in the quadratics. We will then get x squared minus 2x minus 4x plus 8 is greater than 0. When you pull out x from the first two terms, we get x into x minus 2. By keeping x minus 2 as a common factor for the remaining two terms, we can pull out the common term minus 4 and we can rewrite it as minus 4 into x minus 2. To double check your answer, when you multiply minus 4 by x minus 2, we get the last two terms in the quadratics, that is minus 4x plus 8. Pulling out the common factor x minus 2, we then get x minus 2 into x minus 4 is strictly greater than 0. Now, note that when you multiply these two factors, the value will be greater than 0, right? So, now how will x minus 4 and x minus 2 be? Now tell me, when will the product of two numbers be greater than 0? Either when both are greater than 0 or when both the terms are less than 0, right? The same case applies here. The two factors should be either greater than 0 or they should be less than 0. So now we get either x is greater than 4 and x is greater than 2 or x is less than 4 and x is less than 2. To check further, let us draw a number line and let us denote these values there. Now since x is greater than 4 and x is greater than 2, the values common between these two intervals will be the solution. Keep in mind that whenever you get the term and, then in such cases, only the common terms will be considered. So for the first set, we get interval x is greater than 4 and the other set of intervals x less than 4 and x less than 2, we get the common interval as x is less than 2. So we understand that the quadratic curve passes through 2 and 4 and the open interval minus infinity comma 2 and 4 comma infinity will contain the solutions of the inequality x square minus 6x plus 8 strictly greater than 0. Now, the second method is graphical method. We will first sketch the graph and then find solution from the graph. So you don't have to find vertex and y-intercept to sketch this graph. It is enough if we find x-intercept, that is the critical points to plot the graph. So when we factorize this inequality, we get x plus 3 into 2x minus 1 is less than or equal to 0. From this, we get the critical points as minus 3 and 1 by 2. Since the coefficient of x square, that is a, is equal to 2 and 2 is also greater than 0, this graph will be concave up. And the graph will be like this. When you look at this graph carefully, you can surely identify the places where the curve is less than or equal to 0, right? So the solution of this inequality will be the set of all x such that minus 3 is less than or equal to x less than or equal to 1 by 2. Or you can also read it as the set of all x such that x belongs to the closed interval minus 3, 1 by 2. So in this video, we saw how to solve a quadratic inequality using algebraic method and graphical method. Examples of this topic will be explained in another video. If you have found this video to be useful, do share it with your friends and family. If you have liked this video, click the thumbs up button and subscribe to Fun Maths Academy to get notified about future videos. Thank you.